All right, so this is CSC535. The Angel course is not open because you've probably noticed the web server is down or something here on campus. If any of you are trying to do email and play video games and crap like that during class, you'll see the network's really slow, so just bear with it and at least pretend like you're paying attention. So that's me. Call me Mike, Yo Fatty, Awesome Fat, whatever you want. For those of you who've seen me around campus, I kind of look like a goofball. Quick backstory is 15 years ago, I used to be the #1 ranked distance eater in the world. That's where the name Awesome Fat came from. So Awesome Fat was the name I had on TV. So if you have ever watched people on TV eat ridiculous amounts of food, I was one of those people.
So what was your favorite?
I was a beef specialist, and I have the world record in beef at 17 pounds, 2.5 ounces, in 41 minutes.
Oh, man.
So,
yeah, that is awesome.
yeah. So, and for the last 15 years, if you watch Travel Channel or anything, you maybe have seen me on Man vs. Food or Big Beef Paradise or some of those different shows. About 6 months ago, I was in Las Vegas eating a 12.5-pound burger for this autism charity, and I ripped a hole in my stomach. I finished the burger, but I ripped a hole in my stomach, and then I had surgery about 3 months ago. So I'm a has-been now. I can't do it anymore. I maybe 2.5 pounds is my limit. After that, I get sick. Now I'm a normal fat guy at this point. So it's in the past. Good thing. Horrible for your health. Tell you that much. Terrible for your health. But I am famous.
Duly noted.
So it's the trade-off. Good thing for me. Historically, even before that, so give you a little more backstory. I used to play professional tennis. And I broke my back. So I played at University of Illinois, Urbana-Champaign, and then played in Futures Tour events in tennis. Broke my back, had a brain to fall back on, went and got a PhD in computer science, got really fat in the meantime because I wasn't playing 7 hours of tennis a day and eating 17 pounds of food at a sitting. So anyways, now I have a PhD in computer science. I've had it for a while. I run a couple different software companies and also named Awesome Fat now, although we just sold. So now we're out-of-the-box apps under a different umbrella. But in any case, that's my story. How many of you have had Dr. Locklear or Professor Wall in classes up to this point? Okay, you will like me better. Who's had Professor Wall? You should like me better than him. Who's had Dr. Locklear? Definitely you'll like me better than him. Okay. So he's too serious, right?
He jokes.
When I first came here, this is my 8th year at Concordia. I've been teaching for almost 16 years now, I guess, 50, whatever. I thought he was like complete dry, like I'm not gonna get along with this guy. Yeah, he's actually funny. You don't think he is because you think he's so formal and stuff like that. When you start talking, then he's funny, which makes it actually funnier. Okay, so let's start talking about what we're talking about in here. How many of you have had some programming in the past? Okay, well, I know you've had me in class. Was that your first class?
Yeah, that was 150.
It was 250.
20.
Yeah. Okay. What languages?
I do VB.
Okay.
And I did the web systems course. So
Okay. So you've previously done Visual Basic programming, or is that what you do for a job?
I do it now.
Okay.
Yeah, VBA and regular VB.
Okay. Got it. Who else? Who else has had some programming? Besides my class? Okay. Back there?
C, C++, Java, assembly, PHP.
Let's keep going down the list. Okay, so obviously I'll assume everybody's had tons and tons of programming. I make the assumption, since this is a master's in IT, so depending on what your background is, some people come in who've had quite a bit of programming, some people come in who've had no programming. So we make the assumption in here that you've never programmed before. So we'll start off real slow. So for those of you who are busy, try not to snore or who get bored, try not to snore too loud. I guarantee I'll make it harder quickly because we only have 8 classes. You know, each class is 4 hours long. It's the stupidest format you could possibly have for learning programming. A student in and of themselves is only going to be able to process this crap for maybe 2 hours in an evening. Maybe. Yet, we're going to babble on for almost 4 hours because we have to fit it all in 8 weeks. But I get paid either way. So it's your problem. I didn't make the rules. If it was up to me, this would probably be a 2-hour class that meets for 16 weeks or at least meets twice a week or something like that. But whatever. So let's start talking about computer programming. So some of you had programming. If you had to give me a definition of what programming is, what would you say? What do you think programming is?
Write a program using a special language.
To write a program. Programming is to write a program.
Is it like commands,
To me.
instructions?
Okay, set of commands. Okay, what's the ultimate goal of writing a program?
Solve a problem.
Solve a problem. Specifically, tell the computer how to solve a problem.
Sure.
Okay? So, the whole reason we program is to semantically tell our computer to do something for us, right? Okay, we do this through something called a programming language. What do programming languages do?
They translate what the user wants to the binary machine language to tell the computer to complete a task.
What does English do? Let's talk about our normal languages.
To explain idea.
To do what?
To explain idea.
Okay.
To communication.
Express information. Express an idea. So we use English to talk to, or whatever your native language is. We use English to talk to somebody else, express ideas back and forth, right? Okay. Now, are computers smart? Computers are dumb, like toddlers, infants. They can't do anything. In fact, you got to tell them each individual little tiny thing. Now, how many of you consider yourself good problem solvers? You're a Visual Basic programmer. How could you be that great of a problem solver?
Thanks.
I hate Visual Basic. We'll talk about Visual Basic, actually. So, good problem solver. Who else is a good problem solver? Who's a crappy problem solver? Always have one taker. Okay. So, some people perceive themselves as being better at solving problems than other people, right? You know, some of us are just quick on our feet. Other people kind of stumble over stuff, right? How many of you bumped into a wall on your way to class today?
I did yesterday. Does that count?
Were you texting?
No, I actually turned too fast.
That's actually kind of bad. An acceptable excuse would have been I was texting and just, bumped into all sorts of stuff. But if you were like looking where you were going and then you zigged when you should have zagged.
It was going into that classroom over there, so I mean.
Professor Wall.
Yeah.
Yeah, so you were distracted.
Yeah,
I get it.
pretty much.
Okay. So, now, why didn't you bump into walls on your way to class today? I mean, what are the chances that every single one of you came to class today and didn't hit one wall? How many of you thought about that you might hit the walls? It's like, whoa, there's walls here. We need to be careful. How many of you thought about that? Yeah, every single one of you. Good. How many of you recognized you were thinking about it? None of us, right? Human beings are so good at problem solving, we don't know how we solve problems. Since birth, we've been solving problems, and we've gotten so good at it that it's hard for us to slow down and think about how we solve problems. So, tell me, so most of us drove here, right? So you kept coming in from the parking lot. How did you get to this classroom? Specifically, tell me how you got to this classroom.
Walk. I mean, you can go through the.
What's walking?
Yes. And I know
Yeah, but hold on. But what's walking?
Putting one foot in front of the other and progressing forward.
To use my
Okay, so we're gonna start off just so we have some sort of baseline that I know what my foot is.
okay.
Okay, so I got a foot. I got 2 feet. Okay, and we'll even be nice. I'll be nice to you, and I'll say I know my left from my right. All right. So how do I walk?
I just told you.
Well, I don't know. Okay, so say it again. I think I'm gonna crash hard if I do what you said.
I said you put one foot in front of the other and progress forward.
Progress forward. What does it mean to progress forward?
Move
I learned this when
in
I
a
was
forward
baby.
motion.
Hey, you learned it when you were a baby. You got good at it, and you forgot how you got good at it. You forgot what you're doing. Now it just sort of happens, right? Okay, so what do? You put one foot down, lift the other foot forward, lift the other foot up, move it forward, and fall forward. Catch yourself. Rinse, lather, repeat, right?
Yes.
So walking is essentially you falling forward over and over and over and over again, keeping yourself from falling flat on your face each time.
Pretty much.
That's what walking is. Now, how many of you worried about falling down when you were walking into the school today? Once we get a little farther in the winter and we have ice, then maybe not a fair question, but we don't think about that stuff, do we?
No.
It comes so naturally to us. How do we solve problems? Let's start a new slide here. How do human beings solve problems? If you were teaching a class, because everybody in here, minus him, said that they're great problem solvers, right? Everybody. Come on in. I always think it's funny. They stand on the door and they act all nervous, like, oh, is he going to be pissed? I don't care. I get paid either way. We're recording it all. By the way, I do record all the lectures. So you get screen captures, you get my beautiful voice, and assuming that the computer doesn't screw up and drop the lecture, I upload it online and you can watch it again and again. It's entertaining. Good way to go to sleep at night. So if you were teaching a class on how to solve problems as a human being,
Yeah, what kind of problem?
well, any problem. He was telling me about he learned how to walk when he was a baby. So now, as an expert walker, I'm going to put you in charge of a classroom of babies. And you're going to teach them how to walk. How do we solve problems? How do human beings solve problems? We have a huge, big classification of problems, don't we? More problems than we can even think of. How do we do it? Memory. See, she's cheating.
To put the details for the problem.
We all rely on our memory, don't we?
Yeah.
What if you couldn't remember stuff?
Then it sucked to be you.
More than suck to be you. Imagine if you, I always use the example, you've seen the different movies that have people who have like short-term memory loss, right? When you tell them something and 30 seconds later they forgot what you told them. And we think it's funny when we're watching it in the movie, right? Think about how debilitating that would be if you didn't even know who you were, what your name is, that you have feet, what a foot is, what's left, what's right, what's your phone number. We rely on our memory a lot. Could you accomplish anything without a memory? So is it fair to say in order to solve even the simplest problems, we need to have a memory? Okay? So one thing we use to solve problems is we use our memory. Okay, so I'm going to give you memory. So now when you have in your toolbox, you have the ability to remember things. That's it. That's all you have at this point. So the first semester of his baby class, where he taught them, he gifted them with the ability of memory. You know, it's kind of like the Avengers, but like, you've seen the movie Avengers, right?
Yeah, so cool.
Huh?
I said, yeah, so cool.
I know. I wish I was the Incredible Hulk. I mean, none of the other ones even match up, do they?
Nah, Iron Man's pretty tight.
No, come on. He's just technology. That's stupid.
So well. Still cool.
Okay, Iron Man versus the Incredible Hulk in a death match. Who wins?
Well, pretty much Hulk.
Because he can't be killed. He's literally immortal. Just no contest. The other guy, eventually he rusts out.
Sure.
All right, so now we have memory. What else do we use to solve problems?
Tools.
Who?
Tools.
Tools. Okay, that's pretty general. Tell me more.
Like specific input. Go deeply to the problem.
Well, let me give you a problem. How about I give you a problem? All right. So I'm going to go out on a limb here. How many of you are cricket players? 1.5 people play cricket in here? Okay, so you're deciding whether or not you're going to go out and play cricket today. Are you? How do you know? Why wouldn't you play cricket today?
I have a class today.
Because you have a class right now?
But you came in late, so you was probably
Yeah, you were playing
before.
cricket. So when you're deciding whether or not you're going to do something, so I'm a golfer. When I wake up in the morning and I decide if I'm going to go golf today, what are the things I'm going to take into account?
Your schedule.
Okay. What about my schedule?
Do you have to teach today, or do you have any appointments, or?
Okay, I'm going to ask
Anything.
questions. I'm going to ask a whole bunch of questions. I'm going to start off by asking myself, how long does it take to play golf? Well, if I'm going to play 9 holes, it takes like 2 hours. If I'm going to play 18 holes, it takes like 4 hours. Okay, so now I need to go into my schedule, and I need to say, do I have a 2-hour or a 4-hour block of time available somewhere in there to play?
Don't forget the driving and preparation.
Your preparation, so maybe I need 5 hours, 3 to 5 hours. Okay? What about weather?
Yeah.
I'm going to ask, I need to find out about the weather. So there's a whole lot of things we need to ask questions about before we can ever make a decision, regardless how good our memory is, regardless if I can remember how to do a golf swing, right? Okay, so the second thing we do is ask questions. Let's get back to that walking thing. So you were telling me how to walk. So I lift one foot up, and then I fall forward, catch myself, lift the other foot up, fall forward, catch myself, lift the other foot up, fall forward, catch myself. We're doing the same thing over and over and over and over and over again, right? Okay. Is that a pretty common pattern in our life? When you solve problems, are we often doing the same thing repetitively?
Yes.
All the time, right? Okay. So repetition. So I like to teach that from a generalistic point of view. Human beings solve problems using these 3 broad classifications of tools. We use our memory, we ask questions, and we repeat stuff. You might be able to fill in the blanks a little bit in between these, but I think these 3 broad classifications of tools help us solve problems. What's a programming language?
Translate language from hypertext to logical. Depend the machine and the.
Nope, that's the definition of something else I haven't talked about yet. Oh, and by the way, let me throw a little caveat out here. Whenever I ask a question, I'm always asking you to answer the question in terms of what I've taught you so far. So there is no such thing as a trick question in here.
So it's a form of expression to tell the machine what to do step by step or task by task.
When I asked you what programming was, what did you tell me?
I told you before. It's a good question. I can't remember.
It's a machine language.
Translation.
Can't remember.
between-
Okay. So all right. So all right. So you told me that we use it to solve problems. Programming is problem solving.
Yes.
Fair statement?
Yeah.
Okay. How do human beings solve problems?
By memory, asking questions, and repetition.
Doing this crap, right? This is how human beings solve problems. What's a programming language?
Say set up instruction which is a machine to run any logical or to solve the problem.
You put up a program in the machine so that it can
We use programming to solve problems. Human beings solve problems this way. Is the programming language the tool that human beings use to write programs?
Yes.
Okay? Now, if human beings solve problems this way, and programming is solving problems, what must that tool provide us?
A language.
Action.
It has to provide us this crap. It has to provide us the ability to remember stuff, to ask questions, to repeat stuff. That make sense?
Yes.
So a programming language simulates, well here, let's say, provides tools
I wrote that in pen.
which simulate, provides tools, well, I mean, you need a whiteout.
Yeah.
Actually,
forgot
I
that.
thought you had a laptop with you.
I did, but yeah. This helps me remember. You
What's
want me
gonna
to
What's
use
gonna
that
help me
memory.
remember? I had to walk into class and ask you what class this was. Man, now it's just 4 hours of filler, right? All right, so programming languages provide tools which simulate how humans, yeah, just same thing, how humans solve problems. So memory, asking questions, repetition. That's what a programming language does. A programming language provides us a way of simulating the way we solve problems in real life. Because human beings are great at problem solving. Okay, and those of you who have never had programming, actually, I'll go out on a limb here and say even those of you who have had programming find programming in many situations difficult. Depending on the problem you're solving, it's often difficult for us to slow our mind down because we're so good as human beings at solving problems. And when we have to think about that, how do we tell the computer to solve the problem? We're used to skipping giant steps. Like when I asked you to tell me how you got from the parking lot to the classroom. If you were telling a person how to get from the parking lot to the classroom, no problem. You know, I'll just go in the front door, head down the hall, veer to the right. You know, you're going to get kind of to this T thing. If you hit the cafeteria, gone too far. Turn left. Most of the way down the hall, you're going to see a sign that says computer science. Go in there and listen for people talking. Right? That'll get you there. A human being would be able to follow those directions and get there. Computers, not so much. They don't fill in the blanks like people do. All right, so a programming language has to provide a human being with the tools necessary to solve problems on the computer in a similar manner to how we solve problems in real life. Now think about how difficult that's going to be because it took us 15 minutes to figure out how we solve problems in real life. Why? Because we're so good at solving problems in real life. We're too smart for our own good. What's an algorithm? How many of you have heard the word algorithm before? Okay, if you had to define algorithm, like if I gave you a quiz right now and your entire final grade in this class relied on you answering this quiz perfectly. Okay, step-by-step
It's
steps.
detailed, non-ambiguous.
Oh, you had this from another class.
Effective. Step-by-step procedure.
An unambiguous set of instructions for solving a problem.
Yes,
Fair enough?
there you go.
Kind of like a recipe. It was Dr. Locklear class, right?
Yes.
Interesting story. Recently, he sent an email out to, we had a computer science get-together for our undergraduate students, and he sent an email out to Professor Wall and myself telling us to wear our computer science shirts that, you know, the dress code or whatever was lifted for that day. And I pointed out to him that he was ambiguous in his request. He didn't talk about the rest of the clothing I was supposed to wear? You know, don't you believe that your professors should practice what they preach? I mean, if they're telling you that an algorithm is a set of unambiguous instructions for solving a problem, shouldn't he then give unambiguous instructions?
Yes.
I was very disappointed. Okay, so a set of unambiguous, how do you spell this? US instructions for solving a problem.
A detail.
Whatever. You like that? You like detailed?
Yeah.
A detailed
There we go.
set of instructions, set of unambiguous instructions for solving a problem. Kind of like a recipe. How many of you like to cook? How many of you like to eat? Okay, so pick your favorite food. Whether you're cooking it or not, don't you want whoever's cooking it to follow a recipe?
Yes.
As opposed to, I mean, some people are good enough cooks that the recipe's in their head, right? But if they just kind of wing it, this is the first time they're making something, and they don't follow a recipe, isn't that a problem? Like, let's say you were teaching somebody how to make a lasagna. You like lasagna?
Yes.
Okay, so you're teaching somebody how to make a lasagna. How do you make how many of you have made a lasagna before? 2 people? Okay, how do you make a lasagna? You're going to teach me how to make a lasagna. Tell me about it. How do I make a lasagna?
Why are you looking dead at me?
Well, I can look at her too. You're one of 2 people who raise their hand, and you're in my line of fire.
Gosh, that was so long ago.
You have to do it in layers. Like you have to layer like the. Well, you have to. Okay, do you want to start at the beginning?
Oh,
Gather
I want an algorithm.
Gather your ingredients, your cooking utensils.
What ingredients am I going to use?
Hamburger and spaghetti sauce.
Lasagna noodles. Well,
Yeah.
Okay.
Mozzarella cheese.
ricotta cheese.
Okay.
And
Just hamburger, no Italian sausage or anything?
you can use Italian
Oh,
sauce.
well, this is your recipe.
That's my recipe then. I don't do it in my recipe.
Okay.
I'm asking a question.
Okay, so I got all this crap. Now what do I do with it?
Okay, so you fry the hamburger or whatever meat that you have. Mix it with the sauce. And then you have your pan and you want to make it in layers. So you do like a layer of the meat and sauce on the bottom.
Mm-hmm.
And then you put
Then layer noodles
noodles.
and your cheese.
Mm-hmm. And then meat, sauce.
And cheese.
Another layer of noodles
And cheese.
and cheese.
And when do you stop?
When you get to the top.
Yeah, when you get to the top, or you all out.
Or you
of
run out of
ingredients.
crap.
Yeah.
Okay,
And
you
then
get to
put
the top,
a big
you
layer
run.
of cheese on the top.
Okay, so I got that. Now what?
You put it in the oven. Actually, you preheat the oven beforehand to what 450, 475, something, whatever
Depends
you
how
want
hungry you are and how quick you have to cook it.
Exactly. And then after the oven is preheated, you put your casserole of lasagna or whatever you want to call it, casserole dish
Mhm.
of lasagna into the oven. Set the timer for however long you need to set it for, and once it's done, you take it out, let it cool, cut it, put it on a plate. If you want to put some little basil on top to make it look
So now
pretty.
you're teaching me how to eat lasagna.
Hey, look.
I got that handled. Okay, so now somebody who wasn't following a recipe for making lasagna, or somebody who possibly skipped steps in the recipe, maybe they don't preheat the oven.
Mhm.
How many of you who cook have ever put something in the oven, thought you had preheated it, thought you had even turned it on, came back 45 minutes later, thing hasn't been cooking? Or know of people who've done that. That happens, right?
Yeah.
Yep. Okay, so recipes are very important that you follow things in a certain order. Some things can happen at the same time or can happen out of order, but they all must happen, right?
Yeah.
So an algorithm recipe, same exact thing. Okay, you cannot accomplish that lasagna unless you follow the recipe. Hands down. Okay? Why do we, well, let's go this route. Okay, so that's what an algorithm is. We need to get good at writing algorithms. We need to get good at creating recipes. And this is the part that we're not very good at. Because even that little recipe there for lasagna, was not detailed enough to tell a computer how to make a lasagna.
Computer can't make lasagna.
Because we made all sorts of assumptions about things that human beings knew how to do. We talked about this thing called the oven, whatever that is,
It's an object.
and what preheating the oven means, and all this other. I mean, there's so many details in that, right? For human beings, we have a basis of knowledge that we can operate off of, but for computers, they don't. So we have to describe everything to them in the most minute detail possible. Okay. So I said that programming languages have to provide us with equivalences to these three things. How do we handle memory? How do we handle asking questions? How do we handle repetition? Programming languages provide us memory through something called variables. They provide us a simulation, the ability to simulate asking questions through something called conditionals. You say if statements. And repetition through loops. It doesn't matter what programming language you're using. It gives you tools that simulate these three things. Okay? Whether it's Visual Basic, Java, PHP, C#, Forth, really old language. Doesn't matter. All programming languages are the same. The only thing that's different is the syntax. They're all trying to accomplish the same thing. You know, if you're speaking English or you're speaking Spanish, those are natural languages that are meant to communicate with people who understand that language, but you can share the same kind of information, right? I can ask somebody, where do you want to have lunch in Spanish? I can ask somebody, where do you want to have lunch in English? Okay, we're still solving a problem. Okay. So that's kind of a high-level overview of what we're going to be trying to deal with here. But now we need to talk about languages in general. Languages. There are three types of programming languages. We have high-level languages. We have low-level languages. And we have I'm getting very sick of spelling languages. All right.
Yeah.
Languages, there.
You don't have spell check on this thing?
I do, sort of. I'm just going to stop using it. I'm just going to stop typing languages, and it'll be assumed. Okay, so we have three kinds of programming languages: high level, low level, and machine language. All right, machine language. Zeros and ones. So how many of you have the little 2-key keyboard at home? Get out, do your Visual Basic programming, just pop out the 2-key keyboard, just keep hammering it out.
Thanks. Yes.
0001, 000111110. Why not? We would drive ourselves insane.
And we have to interpret that in regular.
Now, there's no
English.
interpretation there. We're talking right to the machine.
No, I mean for us, humans mentally, they'll have to put it into, just break it down
Okay.
from English.
Instead
to
of
the machine
instead of
language.
using tools that allow us to do what's easy for us and have that translated into what's easy for the computer, we're going to just talk directly to the computer. We're going to go down to the computer's level and just talk zeros and ones.
We're just doing too much.
Why should we be inconvenienced? Right? That's the computer's problem. All right. Low-level languages have a one-to-one relationship with the CPU. And let me do this other one, then we'll talk about that for a second. High-level languages have a one-to-many relationship with the CPU. What's a CPU?
A central processing unit.
Okay, that's what it stands for. What is it?
The brain of it.
The brain of the computer.
Yeah.
It controls hardware.
Okay.
The centralized location.
Controls hardware. All right, tell me more.
It controls the hardware and software.
Hardware and software.
It's a central point of administration for hardware and software, same thing.
It manages.
How does it accomplish that? So all those things you said, I guess, are relatively true. How does the CPU accomplish that? What is it, first of all, physically? If you saw, how would you know a CPU in the wild if you saw one?
It uses hardware resources like
Well, no, I mean, you're walking down the street and there's a CPU laying on the sidewalk. How do you know it's a CPU?
small chip,
What does it look like?
small chip.
Little square chip thing, right? Okay? With a bunch of probably little metal rods coming out of the bottom of it. Right? That's what a CPU looks like. Okay, so we saw one of these dudes climbing around in the grass. All right, now, how does the CPU accomplish its goal? You said its goal is to communicate with the hardware, to communicate with the software, to act as the central brain, to do all the thinking, blah, 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 right? How does it accomplish that?
It has memory.
It does have memory. I agree. It doesn't tell me how it accomplishes it.
Translate 0 and 1s into high volume and low volume.
Okay. Hmm.
Follow all the
It translates the programming language.
I
to
like
zero.
this idea of translates. A CPU knows how to do a bunch of magic tricks. Okay? So we take our Intel processor that's sitting inside of one of your computers, let's say the Intel i7 processor, which is one of their latest, greatest chips, blah, blah, blah. It has a big, long list of things that it knows how to do. Okay? Now, from our perspective, each of those things doesn't seem like it's doing all that much. Maybe one of the things it can do is move a piece of data from this place to this place, and we're supposed to be impressed. Maybe another thing that it does is it takes something that's in this place and copies it into something that's really fast, some piece of memory over here. So it's all these little tiny granular magic tricks that the CPU knows how to do. Big old list of them. Okay? Now, each of those magic tricks represents part of solving a problem. And if you call enough of those magic tricks in a row, in the correct order, a problem gets solved. All hard problems are made up of a bunch of easy parts. So pick the most complicated software you've ever used, whether it's Microsoft Windows or Photoshop or Illustrator or some video game, whatever it is. Okay, it doesn't matter what that program is. I guarantee if you were to look at the source code, you're going to see the same crap we're going to write in here in a beginning programming class. You're just going to see a lot of it. Okay, instead of it being a program with 50 lines of code in it or 60 lines of code in it, you're going to have a program with thousands and thousands and thousands of lines of code in it. So all hard problems, all complicated programs are made up of a bunch of easy parts. Just like our CPU has a whole bunch of little tiny granular magic tricks, granular things it knows how to do. And ultimately, we tell our CPU how to solve problems by saying, do magic trick 1, followed by magic trick 8, followed by magic trick 17, followed by magic trick 3. Poof, problem solved. Okay? That's what a CPU does. Okay? Now he said something about zeros and ones. A CPU translates low-level languages into zeros and ones. So it's a translator. At the end of the day, we're feeding a low-level language to the CPU. And the CPU looks at each instruction of a low-level language, which, by the way, remember, low-level languages have a one-to-one relationship with the CPU. So every instruction of a low-level language equates to exactly one, I call the magic trick. One magic trick that the CPU knows how to do. Okay? But now, the CPU is going to take that low-level language, that instruction, and it's going to map it to some machine code that represents a magic trick that it knows how to do. So inside this CPU, the CPU we see when you go to newegg.com and you buy a processor, it's a nice little chip, and you can see all the little prongs on the bottom of it. Then it has kind of a metal topping that helps dissipate heat. Then it comes with a giant fan to help dissipate heat even more, right? All these parts. But the actual processor, you're seeing the finished product. You're seeing a printed circuit board. But before that, somebody had to invent that processor. What do? Well, they had all these wires, and each one of those little magic tricks was actually solved. It's like a little miniature program written in hardware. So somebody had this wire going here, and this wire going here, and this wire going here. So when you put electricity in here, it flows through these wires, and this is what comes out. So if you pass in a 0 and a 1, what comes out is a 1, for example. And that 1 represents the solution to some problem. Okay, so somebody had to solve all those problems by hooking a bunch of wires together and using soldering irons and things like that. And ultimately, after they had it solved, they created the final chip that has all that stuff integrated. Very large scale integration. It's printed circuit board stuff and just whatever. Bunch of crap. Now, so our processor has a whole bunch of mini programs solved on it in hardware. And each one of those solutions, each one of those working algorithms has a code associated with it. And each low-level instruction, each low-level programming language instruction translates to exactly one of those codes. That make sense? Okay. So, low-level languages, one-to-one relationship with the CPU. Now, high-level languages, these are languages that have a one-to-many relationship. Every line of code, that we write in a high-level language may translate into many lines of code in a low-level language, which then translates into many lines of code, many calls to magic tricks on the CPU. Make sense? Human beings kind of like these guys. We like power tools, right? We like to write less and see more. All right. So, 3 types of programming languages. We have high-level languages, we have low-level languages, and we have machine languages. Here are 3 types of programming languages. Just right there. We have functional languages. We have procedural languages. And we have object-oriented languages. So we have 3 different types of programming languages.
So you said the high level and low level.
3 types of programming languages. High level, low level, machine language.
Okay, 3 types. This one is 3 types.
Yeah, here's 3 types. I don't get what you're confused about.
And the quiz, what's the answer?
All of them are the answer.
Any of those.
I'm not even
All
done.
the-
There's going to be another slide that says 3 types. There's going to be another slide that says 2 types. And
Should we write the all 6
Yeah.
or just
you just write everything, and I mark it wrong.
okay? So ask about 6.
Each of these slides deals with programming languages from a different angle. Okay, so this one, there's 3 types of programming languages from the angle of how the instructions in those languages relate to instructions on the CPU. That's what this first one's talking about. Okay. This next one's talking about 3 different types of programming languages from the perspective of conceptually how do we solve problems using these languages. All right. Functional languages are a little bit weird. I'm just going to kind of gloss over it like super quick. Functional languages use functions to solve problems. which is a very, very, very ambiguous thing to say. Let me actually just let that ride for now. I'll swing back to functional languages here in a little bit when I have a little bit something else to base it off of. Okay? Functional languages are not going to be important to us in here. All right? But I'll give you a little more explanation on that. But these other two are important.
So should we star those two?
I don't care. I'll never ask you about functional languages.
Okay.
Let's go that route.
Cool.
It's not that they're unimportant in the big scheme of computer science. They're just very pigeonholed into where they're used. Okay, so procedural languages tend to be linear in nature. Oh, I like that word, monolithic. It's a good one. Procedural languages tend to be linear in nature and are monolithic and have a monolithic main. That'll make more sense too as we talk more about this stuff.
Okay, so me asking you what that is kind of...
I'll fill in the blanks here fairly shortly. I just have to have a little more context to do it. Okay, but that's what those guys are. In fact, here I'll talk about procedural languages a little bit right now. Procedural languages tend to be our little bit older programming languages. So some examples of procedural languages might be C, Pascal, COBOL. Okay? These are older languages, not necessarily bad languages, but older languages that do, I would say, a less realistic job of simulating how human beings solve problems. Okay, so think when a human being solves a problem with a procedural language, we just basically feed it an instruction after an instruction after an instruction. Do this, then do this, then do this, then do this, over and over and over again, giving us this linear nature to our program and just a big old monolithic main. And what I mean by monolithic main is in a little bit, I'll say something to the effect that all programs begin and end with main. We have this thing called a main method. And when you run your program, it starts at the top of main and keeps going to the bottom of main. And it might take some twists and turns somewhere in the middle. Okay? But procedural languages tend to produce very monolithic mains. Monolithic meaning huge and scary. Okay? It's a technical term.
Very Webster-like.
So, object-oriented languages represent the way human beings solve problems much more precisely. These are much newer languages. These guys tend to I need to come up with the perfect way of describing this. This is going to be good. Can I even spell this? Encapsulate. These guys encapsulate detail inside of objects. And we solve problems using the public interfaces. Now, of course, having a PhD, I love explaining easy concepts in a complex way. So now let's take this down and let's talk about it like human beings understand. Procedural languages. Let's say that I brought in an exhibit. You have to use your imagination here because I didn't actually prepare for class. So let's say that we have a telephone laying here on top of this table. Okay, or desk, whatever the heck this is. All right. Now you walk in the door, and I tell everybody, identify what's on this desk. Take out a piece of paper, put your name on it, blah, blah, blah. But what you see up here is a big old pile of wires. Just a big stack of wires, and as you're kind of digging through it, you see, there's a handset somewhere, and you got kind of the dialing button somewhere in there. But to you, at a glance, it's a pile of wires. Can a pile of wires be a telephone? What's a telephone? Something you can make phone calls on, right? Could I have a pile of wires there that technically could make a phone call? Sure. They're all hooked up in the right way. Doesn't look good, but you can still make a phone call with it. Same thing. You can have a lasagna. It's all put together real nice and stuff like that. Or you can have a pile of lasagna parts. Probably still tastes pretty good, right? Same crap. In fact, usually after you get into it, if you're too hungry, it becomes lasagna parts real quick anyways.
Yeah.
So, I could have the procedural version of a telephone sitting on here, where you see all the details, everything, all the inner workings. But when you actually use a telephone, do you need all those details? No, you need the buttons and the handset. That's it. Okay? All that other crap is just details that's behind the scenes. How many of you have a cell phone? How many of you have a cell phone but didn't raise your hand? Okay, all of us have cell phones, right? Or at least most of us probably have cell phones. What's inside that little plastic container or whatever your cell phone's in?
Chips.
Chips and crap. Right? That's that's the exact technical way of describing what's in there. Chips and crap. Okay, that's what's inside of your cell phone. How many of you understand exactly how the inside of your cell phone works? We are impressed that somebody created that and it makes our life easier, right? But we don't care. Okay, you drop your cell phone in a toilet and it stops working, do you open it up and think about soldering on new chips and stuff like that? Or do you go back to the Apple store, or the AT&T store, or Verizon, and you lie about what happened? You just stop working. And then they catch you in the lie, they're looking in there with a microscope, and they see like, the iPhones have metal inside the headphone jack that quickly oxidizes when water touches it. Like, no, this has been in a toilet. Or a puddle, probably a toilet. So, as consumers, as the users of those devices, we solve problems with our cell phone all the time, right? How many of you used your cell phone today? And most of us probably didn't even use it to make a phone call. We checked our email, or we sent a text, or we did all these other things that these phones do today, right? Okay? As a user of it, we don't care about the details as long as it works. We care about the public interfaces. We care about the features that it exposes to us so that we can accomplish what we're trying to accomplish. We don't want to see the chips and crap. That make sense? Yeah. Procedural languages show us the chips and crap as well as the public interfaces. Object-oriented languages just show us the public interfaces. They wrap all the details, which we know are there. Look, we'll take your word for it. Put it in a nice plastic case, or if you're Apple, put it in a glass case and charge us 3.5 times for it. Okay? But hide it from us. We don't want to see it. Make sense? So object-oriented languages are a more modern approach to problem solving because they allow us to solve problems in a way that's more like human beings solve problems. Now I want to emphasize here that the object-oriented version of a telephone, like we're using here in our example, does not have less detail. Just once we've written that detail, we hide it from the user, the person who's going to use that object. And sometimes objects are defined in terms of other objects. So inside of that telephone, aren't there probably other objects that are built with their own detail that then have public interfaces? And maybe inside of that guy, there's other objects that have their own detail with public interfaces, so on and so forth, all the way down to a very, very small microscopic level. Okay? So the way human beings solve problems is in terms of those public interfaces to real objects. Whether we're building something out of Legos, whether we're building a house, whatever it is. We use a whole bunch of different types of objects, a whole bunch of different types of tools, and we put them all together to solve a problem. You're mowing your yard? Well, you have a lawnmower. Lawnmower has internal parts. You didn't build it. You just know that you put gasoline in it and you pull the ripcord. You can push it around your yard and your grass gets shorter. Then maybe you have the leaf blower thing, right? You go around and blow the leaves off. That's another tool. Inside that, there's a motor. What's the motor have? A motor has rotors and all these other things. It has all these parts that we don't have to understand in order to use it. Right? Okay, so Procedural, we see all the details. Object-oriented, we only see the stuff that's important. Make sense?
Yes.
And if we had to get to the details, we can. Somebody had to write the details. In your apartment or your house or something like that, most of us have drywall up, right? You walk in, you have walls. Behind those walls, you know that's where the wires and crap are, and you know that if you need to pass an Ethernet cord from one room to another, that, well, if you drill far enough and fast enough, you will get through the wall. And then you can push the cord right through the wall, right? But there's details behind those walls that you don't need to see most of the time. So that's the difference between procedural and object-oriented. Make sense?
Yes.
Okay. Let's see. Do I have any more 3 types of programming languages? There are 2 types of programming languages. General purpose and domain specific. So these are the different kinds of programming languages there are in terms of the types of problems they were designed to solve.
The term of what?
The types of problems they were designed to solve.
From which prescriptive?
I just said that. 2 types of programming languages. These are the kinds of programming languages from the perspective of the types of problems the languages were designed to solve. It'll make sense here in a second.
And the other one you said was how we use them. The other 3 types?
This one?
Yeah.
Yeah, this is how we use them, and this is how they relate to the CPU.
Okay, thank you.
Okay, so 2 types of programming languages. We have general purpose and we have domain specific. General purpose languages are languages specifically designed for solving a broad classification of problems. General purpose problems. So general purpose programming languages tend to be very large, tend to have lots of moving parts, lots of built-in tools, because the types of problems that they're designed to solve are literally infinite. Okay? So they gave you a big old toolbox so you can solve all sorts of different crap. Domain-specific languages are built for solving problems within a very specific... Nobody has good ringtones anymore. I mean, I want like songs. Sometimes I like to dance a little bit. I mean, it breaks up the time. I mean, 4 hours. I mean, come on. Like, you guys are sitting here for 4 hours. Can you imagine being up here talking for 4 hours? What do you think this does to my singing voice tomorrow?
Do you sing too? What do you not do?
No, I don't sing. Ask my wife. I am an avid golfer, though.
Okay.
That's my sport now. After 10 years of pain with my back and I lost some weight, now I golf all the time. That's my thing. So that's all I care about anymore is golf and putting up with people like you.
Thanks. Very reassuring.
I'm doing a pretty good job of faking this so far, aren't I?
Yeah, you did a good job.
Well, it's going to be really funny because this kind of goes back to what we were talking about memory. You know, I rely very, very heavily on my memory. You know, I've been doing this stuff for a while, so all these courses are just kind of in my head. And once I start going senile,
You're going to be talking in ones and zeros, huh?
I have to start preparing for class is what's going to happen. I have to show up with these slide sets done instead of just writing them on the fly. That would be embarrassing. It would be like Locklear.
So you don't put anything up on Angel until after class?
I never even put this, I don't put slides up. I just put videos up.
Oh,
I upload the videos.
gotcha.
I mean, if you ever want the slides, you can just email me or something, I'll send them to you. But I put the whole video up so you can re-experience this. It's the
So cool.
Another funny Locklear story. One of our undergraduate classes, I teach most of our upper division undergraduate courses, like 300 and 400 level stuff, because I don't want to deal with noobs. And so one of the classes he teaches is CSC150, which is like our introductory class, but he also teaches senior seminars. So he gets them on their way in and then gets them on their way out. So he's, he bookends them. Now 150 is a general purpose type class. That's not just computer science majors. It's, it's required for like most of the students in the university. And sometimes he'll teach that class back to back, like maybe 9 a.m. to 10 and then 10 to 11. I'm not even exaggerating. If you walk down this hall, he's usually in a classroom down there, and you walk in at 9:38 and you listen to what he's saying during that minute, and you walk in at 10:38, might as well have a recording going. He's so regimented. It's ridiculous. I mean, as good as I am at being awesome, that's how good he is. That's how good he is at preparing. Just saying. I mean, whatever. All right, what was I talking about? General purpose, domain specific. Okay, so domain specific languages are languages designed to solve a very specific type of problem. Good example of domain specific language would be HTML. That's an excellent example of a domain-specific language. So HTML, Hypertext Markup Language, is the web page language. What's its job? Its job is to allow you to describe content in such a way that it looks pretty in a web page, in a web browser. That's it. You're not writing loops. You're not remembering stuff. You're not calculating the factorial of a number. All you're doing is making stuff look pretty. So the size of HTML is like this compared to the size of Java, which is the size of a mountain, relatively speaking. Okay? Because Java has to accomplish a lot more. If you'd allow me real quick, because it just popped in my head, some examples of object-oriented languages. Java, C#, Objective-C. From my perspective, these are our big three today. So if you were going to be a programmer, notice I left Visual Basic off of this.
Thanks.
Nobody uses Visual Basic anymore. You have to be maintaining some legacy software, updating stuff for a company that's had software for a long time.
Yes. I'm working
I mean, it's cool. My wife's a COBOL programmer, so she's got you one-upped. When I started teaching, I taught at Western Illinois University in Macomb, Illinois. And my wife was a COBOL programmer there 15, 16 years ago, something like that. And when we moved up here 8 years ago, she kept her job there because you can't find competent COBOL programmers. Like, just work remotely. She works on a mainframe. She remotes into a mainframe computer. Who buys mainframes? I know, it's funny. Yeah, but it's just as bad. But anyways, our big three languages today for modern day, high-level, object-oriented languages, and there's a couple other things I haven't taught you about yet, so I can't say them yet, are going to be Java, C#, and Objective-C. Okay? And really, if we had talked about 6 years ago, we probably would have left Objective-C off. Objective-C is the Mac language. And the reason it's popular today is iPhone. So historically, I mean, you have, I'm going to round down and say, a zillion Java programmers and a zillion C# programmers. And historically, you would have had like 5 Objective-C programmers. Okay, but now you probably have several 100,000 Objective-C programmers because of how popular writing iPhone apps has become. And now that's translated into writing Mac apps. Is writing apps for the iPhone versus writing apps for the Mac kind of the same diff? Okay? All right, now a very important question for you. Why a 13-inch MacBook Air?
Why do I choose it?
Yeah.
They said it's faster to boot.
I agree that computers should not exist. If you're going to get a MacBook Air, you get this MacBook Air. The 11.6-inch MacBook Air.
No, this one is clearer.
No, it's not. It's just got a little bit bigger screen.
Yeah,
It's got a
you
13-inch
can
screen.
see more.
Yeah, so why not get the 13-inch MacBook Pro?
That's the one I
That's
want.
already
This
pretty
one
portable.
Lighter, maybe.
This is even lighter.
They want lighter and more screen.
Yeah, see, that's the problem. That's the problem.
I want that.
You want your cake and eat it too is the problem.
Stop being
Yeah,
greedy,
No,
man.
there's no differences between the prices.
What's up?
There is no differences. Maybe 200 differences the prices between the Pro and Air.
Yeah, but I could fit this in my pocket.
How much is it?
Literally.
This one is cheaper, I think.
Yeah, a couple $100. If you got the same specs, this is like $200 less. But this is an inch longer than an iPad. And yours is like a normal size laptop, except it's just thin and light and less horsepower.
Yeah, I need this size.
Yeah, so get a 13-inch MacBook Pro with 5 times the performance and almost the equivalent portability. That shouldn't exist.
I'll change it.
Shouldn't. I mean, they're nice laptops. Don't get me wrong. I'm actually blaming Apple. I just don't think that product should
You mean
exist.
about the CD and stuff?
Oh no, I don't care about that because they took all those out of their other machines anyways. If you go and buy a 13-inch MacBook Pro today, there's no DVD drive.
The Pro also?
No, yeah, the Pros, no DVD drive. The Pro
Maybe
probably weighs
sometime-
20% more than that.
Sometime I need the CD. I don't know why do they.
Who even has CDs anymore? Don't you just steal your crap off the internet? Like everybody else?
How to listen
Some
to
of
music?
us are ethical.
Have you guys taken the ethics class yet?
No. January.
It's in.
All right. So, anyways.
Thanks.
Hey.
Life lesson for 810.
Let's see, what was I talking about? Oh, we're on another slide, aren't we?
Yes.
There we go. Okay. So a good example of domain-specific languages would be HTML. That's probably your best example. Very tiny language that solves a very small problem. Okay, somebody can learn HTML in a weekend. All right? General purpose, we could fill in our big 3 right there. Java, C#, and Objective-C. Java versus C#, our big 2. How many of you have heard of Microsoft? So C# is Microsoft, right?
Yes.
Java, who made Java? Who?
Sun.
You mean Oracle? Sun Microsystems never existed. Java was made by a company called Sun Microsystems. That was later purchased by Oracle. Okay? So those are the dudes who made this. So there's interesting backstory with Java versus C#. Now, we all know that Microsoft follows very, very ethical business practices, right? Certainly, all of these large, multi-billion-dollar corporations only have their consumers' best interest at heart and are not in the business of only making money. Now, Microsoft's business practice, and it's no different than Apple, really. I mean, the law lets them do this. Microsoft likes to steal technology, try to make it better, use their marketing machine to actually be able to sell it, get sued by who originally made the technology, and then settle outside of court. And there's nothing wrong with that. Our laws allow for it. Let's say you're somebody who came up with a product and chances are you're not going to have the resources, financially or people-wise, to take it to market and be successful with it, right? So wouldn't you love for Microsoft to steal your idea, steal your technology, go and make billions off of it, then you sue them for $500 million, they settle with you outside of court, write the check, and you move on with your life and go buy an island? That's our plan, right?
Yeah.
And you're going to thank Microsoft. You're not going to complain, oh, that Microsoft. You got $500 million for something you weren't going to be able to sell anyways, because you're not Microsoft. So, but now this is the funny story here is, see, my voice is already getting tired. You hear this? Starting to crack and stuff. I'm going through puberty. So anyways, Microsoft, well, Sun Microsystems came out with Java first. Then Microsoft said, hey, you know what? We like that Java thing. We like that. Okay, we'll talk about why they liked it in a little bit, because I'm going to kind of pause in the story, because it's like a movie. You got the coming attractions, and you got the commercial break. It's like these commercials are going on forever. Okay? Plus, around 7:30, I'll probably give all of you a break, so I can rest my voice a little bit, like a 5-minute break. So we need to keep powering through this stuff. All right. So, anyways, Java decided, Microsoft decided we really like this Java thing. Great idea. Great idea. Java was kind of born out of an older language called C++. What's C++? C++ is the object-oriented version of C. We've already talked about the difference between procedural and object-oriented languages, right? Now, C had a whole bunch of problems. There was a bunch of crap that was good about it, but there was a bunch of crap that was not bad, but allowed beginning programmers to get into trouble. And we'll point out a lot of these examples as I am teaching you some of the Java stuff in this class. All right? So anyways, Microsoft said, you know what? Screw this. We now have a product called J#. Actually, originally, it was J++. They hadn't figured out that whole Sharp thing yet. This was pre-Sharp. Okay, so Microsoft, they had a product called Visual Studio 6. I think it was the last product this shipped with. Visual Studio 6.0 shipped with one of their tools was called J++. Visual J++, because that sounds cooler. What was this? This was Java syntax in a Microsoft product. Oh, sounds good, right? Well, now, Sun Microsystems is not a tiny company. It's not like this example where I just said, you have a great idea, you don't have the resources or the people to make zillions off of it, Microsoft steals it, you sue them, you get your money, and you're happy. Sun was not happy. Sun really hitched their entire wagon on Java. In fact, how many of you have ever invested in the stock market? Nobody? Okay, on the stock market, every company has something called a ticker symbol. Okay, it's usually a 3 or a 4-digit symbol that represents what a company is, like kind of the shorthand trading name for a company. Sun Microsystems ticker was Java. That's how much they love that technology. So Sun, this is way before Oracle purchased them, got pissed. And they said, you know what? We're going to sue Microsoft. And they did. And they won. So Microsoft, and in the meantime there, Microsoft had come out with J#. It was like, hey, we're still Microsoft. We're cool. We really changed our product hardly at all, but we're going to charge you double for next year's model. Okay? So they came out with J#. Then this lawsuit happens. Now they are no longer allowed to have anything J-based. No Java syntax. That's illegal. So Microsoft goes back to the drawing boards. And I was trying to think when this was. I was in 2000, maybe 2001. I was in University of Illinois at Urbana-Champaign at the Association for Computing Machinery, ACM, at their big trade show. And at this show, Microsoft had their seminar room set up. They gave talks and things like that. All these different companies were there to give talks about their latest, greatest technology. Everybody always goes to the Microsoft one. Why? Because they give away the best free crap. All right? You go to these other guys, they're giving away little bouncy balls with lights in it. No, Microsoft, they're giving away Visual Studio Professional. It's like $600 software. We all stole it off the internet. So we already had it. So what did we do? We took it, immediately sold it on eBay. Now, none of you have had the ethics class yet, right? Okay, so anyways. So I show up to this talk, and this talk is about this brand new language that Microsoft's coming out with called C#. And the guy, and I was a big Java developer back then. I've been writing Java since it was invented. So nothing's better than Java, blah, blah, blah. Only, but back then, I thought I was hot stuff, God's gift to programming. And, I think about it now, think about how much I know now compared to then. I was basically an idiot. I was like the babies that are in his walking class. Okay, so anyways, I thought Java's awesome. Everything tries to be like Java, blah, blah, blah. So this Microsoft guy's there telling me about, we've built this brand new language, C# from the ground up, and it's this, that, and the next thing, best thing since sliced bread, blah, blah, blah. And he's basically describing Java. All the features he's telling us about in this language are Java, but with a new syntax. So did Microsoft just steal it? Well, at the time, I would have said yes. But as we get into this a little bit farther, we're going to see that Microsoft took what was good about Java and then made it better. Okay? So C# is a Microsoft technology. Java is an Oracle technology. But if you go to java.sun.com today, it will redirect you to Oracle's Java page. Okay. So I'm going to pause that story right now. So we don't have enough information yet to tell the rest of the story. So we got to go back to the drawing board here. So we have two types of programming languages, general purpose, domain specific. We have two types of programming languages. We have strongly typed and loosely typed languages. So now, this slide talks about the different types of languages as it relates to the types of variables, or how the variable system works, how they simulate memory. Loosely typed languages, well, let's go on over here. Strongly typed languages require that when you're creating a variable, when you're creating a place in memory to store a value, you must say what kind of value, what type of value that you intend to hold. A loosely typed language doesn't require you to tell it what kind of value you're going to store in there. So the example would be this. If you have a whole bunch of tennis balls at your house, and you need to go to Target and buy a container to hold all these tennis balls, you're going to go to Target, you're going to come home with a big Tupperware container thing, you're going to earmark it tennis balls. Put a little Post-it note on the outside of it, tennis balls. You're going to throw all the tennis balls on there, great. Now finally one day your wife comes home, gets pissed off at you and says, hey, you got to get rid of all these old tennis balls. This may or may not be a true story. Okay? So, you dump out the tennis balls. Now you have a perfectly usable empty container now, right? One problem. Got that Post-it note on the outside that says tennis balls. That's all I'm allowed to put in that container is tennis balls. if I was working inside of a strongly typed language. It's a container built for holding tennis balls. Now, had I not put that post-it note on the outside of it, I could then repurpose that container to hold other crap. Make sense? Okay, so the difference between a strongly typed and a loosely typed language is just that. How much you tell the language about what you intend to store in your variables. Now, I know I told you no trick questions, but I'm going to ask you a trick question. Which is better?
Loosely.
Strong.
Why? Oh, I love it. You got two different answers. Okay, loosely. Why is loosely better?
Because you can use like any number of ways. Like it's not specific to one use.
Okay. Because from a human being perspective, it's stupid to go to Target, buy a perfectly good container, use it for one thing, and as soon as you don't want to store that in there, and then you come across some other crap like old wires or something you want to store, to have to run back to Target to buy a new container all over some post-it note. Right? We don't want to have to do that. Seems stupid. Okay? What's bad about loosely typed languages? See, now this is where that gray area starts coming in. From a human being perspective, well, first I'll make the blanket statement. Very often, the human version of right or the human version of fairness does not translate equally to computers. Okay, computers operate on a whole different time level than people do because of how quickly they are. You know, when I teach the operating systems class and we talk about processor scheduling, you know, human beings, if you go to McDonald's and you get in line, there's a version of fair for human beings, right? Who's in front of the line? The person who got there before you. Human beings' version of lines are first come, first serve, right? Not for computers. Some things are more important than other things. We let them go to the front of the line. What happens if you're at McDonald's and somebody tries to cut in line? Everything's relative to how hungry you are, right? Or if you're like the Mequon McDonald's, who you hear about this in the news?
Sell them weed.
No, not just that. Yeah, there was like 3 different McDonald's along Port Washington Road that were like major drug havens. They were trafficking like major quantities of drugs through the McDonald's drive-through. They just did a DEA raid of these things. One of them was right here in Mequon. It was pretty funny.
The other one was by my house.
Was it?
Yeah.
Is that Brownport?
No, it was the
Glendale?
yes.
Yeah, so I mean it's kind of like Breaking Bad, but in real life, if you've seen that show. So anyways, so the version of fairness for human beings doesn't always translate into computers. So clearly from a human being perspective, a loosely typed language makes more sense. We want to be able to repurpose that bucket because we spent good money on that bucket. And now I'm not using it for tennis balls. I can put whatever the heck I want in there, right? Okay. Now, from a computer perspective, though, from a programming language perspective, a loosely typed language actually has some performance problems. Because before you can use, remember, we're talking about variables here. Before we can use the value stored in a variable, we need to know what kind of value it is. For instance, you don't want to be doing math with things that are not mathable. I made that word up. PhD counts. Okay? Can't do math with things that are not mathable. That makes sense. So in a loosely typed language, somebody's going to have to check to make sure the value is mathable before it allows you to do math with it. Strongly typed language, the programmer actually said what's in this bucket, what's in this container. Okay? We were explicit about it. We said, there be integers in here. So go ahead and math away. That make sense? Okay? Now, even having said that, you still can't necessarily answer the question of which is better, strongly typed versus loosely typed. Because it really depends. Not all programs need to be high performance. Okay, but performance does come into play here. For instance, computers are really, really, really fast, right? How many of you think you have a really, really fast computer at home? Actually, you know, that's actually a very good example for this. Okay, who thinks they have a very fast computer at home? Couple of you. Okay, what we got?
I have a Toshiba i7 core.
Okay, quad core.
Yes.
Okay, and he's got a pile of crap. Okay, so this is a Core i5. Did you go expensive or you go cheap on it?
I mean the price.
Yeah, did you get the upper one or the lower one?
No, the 2000 version. I think it's about 1,100.
Okay, so he got the Core i5. So he's got a much lesser processor than you. Okay, dual core, but his is only running at probably 1.6 gigahertz. Your quad core i7 is a big fat Toshiba laptop.
No.
Pretty bulky
No.
compared to that. Yeah, it's bulky compared to that.
Yes.
So you could if you hit somebody with that, you're a hurt 'em. Okay. Okay. Now, but his laptop has no moving parts,
Sure.
so he can hit somebody with that. All it's going to do is going to bend. Plus, he can finally chop on the onions, the front bezel. Okay, so you have him just destroyed in processing power. How much RAM do you have in your machine? 4 gigs. Okay, I'm guessing you have 2 gigabytes in yours. Probably. Okay. So this is an awesome laptop. This is a pile of expensive crap. Now,
I actually paid much less for mine than you did.
I will change it. Believe me.
hold on. Yeah.
I had it today.
You win in my argument here.
Which are you?
See, I'm building this up.
So
See,
it's-
I'm an
this one
entertainer.
faster. This one is
I'm an
faster.
entertainer up here, people. Yeah. This is not worse than this. I'm about to explain why. Okay, so we've already decided this guy has tons and tons of horsepower, right? This guy doesn't have anywhere near the horsepower. Now, if both of you opened up and went to a web browser and went to www.microsoft.com, is one of them really going to load the page any faster than the other one?
Mm-mm.
They're pretty much going to get there at the same time.
Yeah.
In fact, his machine's probably going to boot up quicker because of the nature of it. But regardless, it doesn't matter that her machine is capable of higher performance. Most of the time when we're using our computers, we're nowhere near maxing out our chips. Most studies show that your computer sits idle between 97 and 99% of the time. So those of you who get these gaming rigs with dual 6-core processors, we have 12 cores, and they're all hyper-threaded, so it's actually a 24 logical core. We got 32 gigs of RAM, and you know what I did? I overclocked it. So what I did is I dipped the entire machine into a bucket of ether. That tennis ball container, filled it up with ether. Put my machine in there. That's coolant. Okay, so you got this awesome, amazing machine, and what are you doing? You're checking your email. You know, Minnesota Slim here can check his email just as fast as you can with that thing, that behemoth that's sitting in ether. Okay, so punchline here is that computers operate on a whole different level. We only need that kind of horsepower when we need that kind of horsepower. We can translate this right back to cars. How many of you like sports cars? Porsches, so let's take an Audi R8. How many of you know what an Audi R8 is? There is one in this neighborhood, by the way. There is. There's an Audi R8. The guy who owns the country club, River Club, just up the street, he owns like a different car for every day of the week. But one of his cars is a silver Audi R8, if you ever see it driving around Mequon. So I don't know. I mean, I don't know that much about cars, but I think that car has something like 1 billion horsepower-ish. Yet he's driving it around in residential Mequon.
Yeah, he's never going to use
Okay.
all of that.
Yeah. So you might as well be on a bicycle, right? You're going to keep up with him in residential Mequon on a bicycle. By the time he gets the thing revved up, he's gone through 3.5 gallons of gas, and he's slowing down. So he has way more horsepower than he needs 99% of the time. Now, if he's on his way to a Packers game, and he goes a day and a half early when the traffic hasn't picked up going north, he could probably get to Green Bay pretty quick. The cops aren't going to catch him. None of the cop cars can keep up with an R8. Now it just becomes a whole ethics problem again, right? Okay, if you're in an R8 and the cop car maxes out 140 miles an hour, let's say, and your R8 maxes out at 700 miles an hour, you technically don't need to stop for the cops. But you will run out of gas before they do. So eventually they may catch, it's like tortoise in the hare. They'll eventually catch up on you when you're on foot. Trying to get to the next city. Okay, so computers operate at a different level. They're meant to fake the human beings out. They're meant to do things super, 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 super fast so that we don't know who's first in line, who's second in line, all that stuff. Okay? Your laptop is every bit as good as anybody else's laptop in here for most tasks. Where you'd really see a difference is, let's say we had a big video. Let's say you took today's lecture and you decided you wanted to convert it to something else to put it onto iTunes or something like that. Okay? So if you try to convert that video on your laptop, it's probably going to take about 2.5 hours. You try to convert it on your laptop, it's probably going to take a little over 1 hour. You try to convert it on like a Mac Pro or one of the high-end Dell servers that has, like 12 cores, it might take like 5 minutes. Because those are problems that you can divide up amongst those different cores. That's where that performance starts making a difference. Not in how we use our computers 98% of the time. That make sense? Okay, so kind of spinning this back to where we were going with this, performance isn't always our concern. It's only sometimes our concern. So a loosely typed language is not necessarily worse. If you were writing a video game that was very reliant on performance, you probably would not choose a loosely typed language. You would choose a strongly typed language because by allowing the programmer to explicitly say what kind of values can be stored in variables, you're taking a level of oversight away from the computer. It does not have to check a variable before it uses the variable because the programmer's told it what kind of values go in there. Famous loosely typed languages are stupid languages like VB.
Thanks a lot.
I worked for a company in Chicago doing VB programming for a while. Nothing wrong with VB. But you can relate to this. In VB, there's about 3 different ways you can even define a variable. It doesn't matter what you put in a variable. Even if you define a variable, in VB, you can define a variable with a type or without a type. You choose. So it's like neither loosely typed or strongly typed. It's just whatever. The other thing about VB, which is funny, is you could put an integer into a variable, do math with it. Then you could put an ice cream cone into that same variable, do math with it, and it will work. What does it mean to add 6 to an ice cream cone? VB will pump out an answer. Okay? It won't make any sense. But it will not yell at you. It'll say ice cream cone plus 6. That's a hot dog. Here. It's just a dumb language. But a lot of stuff was written in VB. You know why? Why was so much stuff written in VB?
Oh, you're asking?
I'm asking you now, before I make fun of you.
Thanks a lot. Well, for me at my company, we usually use like a lot of different Microsoft Office applications to interact with other stuff or each other.
Mm-hmm.
So,
Yeah, but you can use C# to do that.
True.
Why VB? You already got a bunch of programs written in VB, right?
Yeah.
Why were they written in VB in the first place?
Because some people aren't that bright and they don't use it correctly.
VB was originally designed by Microsoft as being a rapid application development environment, RAD. The idea was you didn't have to be, again, talking about performance, business applications typically need to be functional, not high performance. They're not like a video game. You didn't have to be a great programmer to put together something functional using Visual Basic. Visual Basic was meant to allow non-programmers, or relatively non-programmers, to write relatively robust business applications. So you had this army of people writing business applications who were not programmers using Visual Basic. Now, this would have been okay had Visual Basic been a little bit more stringent about the rules. The problem with Visual Basic is it let you get away with everything. So in many ways, old Visual Basic programs are actually hard to maintain because they let the programmers basically get away with murder in them. I mean, you've probably run across some sections of your program that are like, what the hell? I mean, it's interesting. But she's in the same situation as my wife's in that, I mean, you know, my wife wouldn't have a job if it wasn't for this. But Western Illinois University is one of the only schools in the country that writes their own internal software. Most schools use a product like Banner, like we have here for checking your grades and stuff like that. For years and years and years, Western Illinois University has written their own internal software in COBOL. Well, which is cheaper? To update it all to something new or to maintain what's there? Clearly, in the long run, it would be to update it all. But that's not how state money works. State money works like this. We have this much money to spend for this year. The amount of money we have to spend for this year is not enough to change it over to something more modern. The amount of money we have to spend for this year is enough to pay people to keeping what used to work, keep working. Ish, whatever, close enough. Make sense? So they're going to spend 50 times more money in the future until finally just the computers don't exist anymore. Like nothing runs COBOL. then they'll have no choice. But I mean, it's very interesting, actually, that whole world. Okay, so strongly typed versus loosely typed languages. One's not necessarily better than the other, but what should come to mind is if a language is strongly typed, think about performance. If a language is loosely typed, think about less performance, I guess is maybe the easiest way to put it right now.
So Java is strongly...
Java would be strongly typed. Java, C#, Objective-C, C, C++, all those are strongly typed languages. Okay.
So I have a question.
Yep.
I would like to consider VB as an advantage because it's kind of like everybody can use VB. It's not necessary to become programmer.
I don't disagree with the statement, but the fallout is the problem. I mean, what gets produced by Visual Basic because it's so flexible is very random, software of very random quality. If you had a good programmer write in VB and they wrote consistently, nothing wrong with VB. If you have somebody who's not necessarily a programmer write in VB, I don't have a problem with that. I like the idea of a rapid application development environment like VB for creating applications because not everybody needs to be a rocket science programmer in order to create utilities that benefit business. Okay? You know, most businesses that are running VB applications are not selling those applications. They're using it for their internal workings to improve their efficiency. So I don't have a problem with VB in general, where I don't have a problem with the idea behind it. The problem with VB is that it's written to allow you to be extra flexible even within that. You can choose to give a type to a variable or not choose to give a type to a variable. You can choose to define a variable one way or another way or another way. They should have made it, this is how you define a variable. No type. Make it loosely typed, no problem, and make it so that there's only one way to define a variable. So that's just one example as it relates to variables. Those examples are found throughout Visual Basic. They provided the programmer with too much flexibility where you don't get consistent programs written from there. I'm totally for a tool that allows people with business skill to also write automation programs for a business. Totally cool with that. But I mean, I think history would say that I guess history would say I'm correct here because Visual Basic is not popular anymore. In fact, we really don't have any rapid application development environments out there today. We only have legacy things that people are still maintaining, and it's because Visual Basic set the precedent and took a really good idea and screwed it up by letting people get away with too much. I just think at the end of the day, they took something that could be flexible in and of itself. I mean, it wasn't hard. If you only said, this is how you define variables, you don't have to give them a type, that would have been fine. But when you're a programmer, or you're somebody trying to be a programmer and you're looking at sample code, and you see three different examples, and one example says define variables like this, another example says define variables like this, another example says define variables like this, it sends a very mixed message. So what you get is a bunch of programs that are just a hodgepodge of ideas that all just work. You know, Visual Basic gives you very little feedback. You can put all sorts of stuff in there that works. It might not get you what you wanted, but it works. Where I wish it would yell at you a little bit more. So you at least push you down some sort of reasonable path. Yeah, but on paper, Visual Basic was revolutionary. But because Microsoft made those mistakes, it's really fallen off the bandwagon to something like C#. But Microsoft's really taken C# and made it kind of like the modern day VB. So it's kind of all the good things from VB, but with a language that's a significantly more structured language, C#. But I do think that to be a C# programmer requires a higher level of expertise than to be a Visual Basic programmer. There's just more moving parts, I guess. Okay, so 3 types of programming languages. Java is a high level, object-oriented, general purpose. Object-oriented, strongly typed programming language. Is there any more of those things that I need to do? I'm about to take one. Yeah. I just want to make sure I have the right stopping point. I think I got all of those in there. All right, so let's take about let's come back at 8, 14 minutes or so. I'll stop this recording and I'll get it uploaded starting.